In this video, I'm going to go over adding, subtracting, multiplying, and dividing complex numbers. Now, I think you'll find that there are a lot of similarities between complex numbers and just adding, subtracting, multiplying, and dividing, just regular combining like terms. But there is a little bit of a difference. First of all, when we combine like terms, and when we're done, we usually have the variable on the left side, right? We combine that x with the 2x, combine that 7 with the 3, and we get 10, right? We have the variable on this side. But this isn't a variable. This is I. This is the square root of -1, which is an imaginary number. And in standard form, it's on the right. So really, mostly the only difference. There is another one, but that comes into play during the multiplying and dividing part of it. But first of all, let's look at this one. This is addition, right? We're adding this complex number to this one. 3 plus 4i plus 7 plus 6i. Well, it's not plus or minus, it's just plus. Get rid of those parentheses. And what I like to do is I like to underline the like terms, right, in different ways. You know, squiggly means it combines with the squiggly, and normal line means it combines with the normal line. And you can do all sorts of different things. You can use V's or arrows, whatever. So 3 plus 7 is 10, right? And we just combine these just like it's a variable. 4i plus 6i is 10i. That's all there is to it. Because it's being multiplied by I, both of these combine. So their coefficients get added together. The I stays the same, and there's just one I. Okay, that's in addition. There's just one I, and we can't get rid of it. Because it's an imaginary number, it's just going to stay there. Okay, that makes sense. Now, let's go over here to the subtraction problem. Just like any other subtraction problem, when we're subtracting two binomials, we would distribute that negative number to the second number. It changes the signs of everything. So this would stay the same as 2 plus 5i minus -3 minus 3i is the same as, what's -1 times -3? Positive 3. -1 times -3? Positive 3. So it's 2 plus 5i plus 3 plus 3i. That's really all there is to it. And we'll do the same thing again. Combine the 2 and the 3. 2 plus 3 is 5. 5 plus 3 is 8. And there's your answer. All right, now I'm going to go over multiplying complex numbers. And you'll find it's exactly the same as multiplying two binomials together with a small change up at the end. It actually makes it a little adds a little more to the simplifying process at the end. But we're going to start with this one in the middle, just to make the point that even though it's a complex number, we still treat it like it's a binomial. We distribute, when we have parentheses around it, we distribute that number. So 3 times 6 is 18. 3 times 2 is 6. The answer there would be 18 plus 6i. Now, when you have two complex numbers being multiplied together. And that's what the parentheses mean. That means that 4 plus 3i times 2 minus 5i. We still treat it the same as binomials. We distribute both numbers to both parts, right? Or FOIL, as some of you might know it as. First, 4 and 2. Outside, 4 and negative 5. Inside, 3 and 2. Last, 3i and negative 5i, right? So, first, 4 times 2 is 8. Outside, 4 times negative 5i is negative 20i. Inside, 3i times 2, 6i. Last, 3i times negative 5i. This is where things change. Or actually, it's the same. Negative 15. What's I times I? I squared. That is key. Always remember, when you're multiplying I times I, it's I squared. If I had done this instead, distribute the 3i to 6 plus 2i, what would I get? We get 3 times 6, that would be 18i, plus 3 times 2i, 3i times 2i is 6i squared. Now, there's a bit of a difference here. We combine like terms, right? Let's just take care of that while we're thinking about it. 8 minus, what's 20 minus 6? 14i, right? Now, what is I? Well, it's an imaginary number, right? But we actually have a value for it, right? I is the square root of negative 1. Well, what if we have I squared? What happens then? Well, we have the square root of negative 1 times the square root of negative 1, right? Wait a minute. A square root is a number that multiplies by itself to get that number. So, what if we multiply this by itself? What do we get? We get I squared equals negative 1. What? So, whenever you come across an I squared, replace that with a negative 1. All of a sudden, you got negative 15 times negative 1, which is positive 15. And you're not done combining like terms. You got 8 here, 15 there. So that's, what, 23 minus 14i? Now you're done. Same here. That I squared is now negative 1. So what do we get? Negative 6 plus 18i. And that is your final answer in standard form. Make sense? All right, now let's do this one just for practice. FOIL, right? FOIL. 3 times 2 is 6. 3 times negative 5 is negative 15i. Negative 4i times 2, negative 8i. Negative 4i times negative 5i is positive 20i squared. Okay, well, 6 minus, another negative 23i, right? Negative 15 minus 8, negative 23, plus 20 times, replace that I squared with a negative 1. That becomes negative 20, right? So 6 minus 20 is negative 14 minus 23i. All right, close to the end of this video. Now we're going to do dividing complex numbers. This is a little more complicated. 2 plus 5i divided by 4 minus I. Well, what I like to do is rewrite that as a fraction. This just helps me put it in perspective. And really, it should be just a required thing to do, because if you just always think of division as being a fraction, you can't go wrong. You'll always recognize, oh, wait, I know how to do this. We got to rationalize the denominator. What does that mean? Well, if you remember dividing binomials, let's say 2x plus 5 over 4x minus 1, you got to find the conjugate of the denominator, and what you do, you multiply both the top and the bottom by that conjugate. What is a conjugate? Well, a conjugate is the same with one key difference. That sign in the middle has changed. The 4x is still the same, positive 4x, but that negative 1 has changed to a positive 1. And why do we do it to both the top and the bottom? Because if we just do it to the bottom, we're going to mess it up. What we want to do is kind of simplify this to get the same number that we started with, just written a different way. So we multiply by something over itself, because anything over itself is just 1, right? Same principle here. So the conjugate of 4 minus I plus I. Now, it may be confusing because the letter, the variable, is usually over here, but this isn't a variable, right? It's just I. It's the imaginary number. So, parentheses around everything to make sure that you remember that you are supposed to FOIL this out every time. So we're doing more multiplication practice. 2 times 4, let's just write it down here, is 8, right? 2 times I is 2i. 5i times 4 is 20i, and then 5i times I is 5i squared. Oh, there's that I squared again. And the bottom. Now, there's a reason why we do this conjugate thing, and you'll see here in a minute. 4 times 4 is 16. 4 times I. Okay. Negative I times 4, negative 4i. Negative I times I is negative I squared. Now, why did we multiply it by the conjugate if we're still just going to get a mess? Well, what we're trying to do is get rid of the I in the denominator. We don't want an imaginary denominator. We want, actual solid denominations of whatever we're doing. So when we combine like terms here, wait a minute, 4i minus 4i, that's going to be 0, right? And then take our I squared and we change that to negative 1 like we learned earlier, right? 16 minus negative 1 is 16 plus 1, actually. So that's 17. So our denominator is 17. What's our numerator here? 8. That becomes negative 5, right? Because of the I squared. Negative 1, right? So we got 8 minus 5 is 3 plus 22i over 17. And that's your answer. Well, some teachers might want you to split those. There's your answer in standard form. One more thing I wanted to review before I end this video is the pattern that emerges with complex numbers. So we've talked about I as square root of -1. Well, and we talked about if we have I squared, we get -1 because we're multiplying square root of -1 times the square root of -1. Well, what happens if you have I cubed? Well, you got square root of -1 times square root of -1 times square root of -1, right? It's 3 of them. Well, 2 of them become -1, and then we're still multiplying by the square root of -1, so it's just -1i or -i. Okay, so that's -i. What about to the 4th? Well, it's the same thing. There's another one on there. So these two become -1, and these two become -1, and these multiply together to get +1. So I to the 4th is just +1. Okay, so we're not always going to get some nice -1 number, right? Well, what happens if we keep going? What's I to the 5th? Another one, right? -1, -1, +1. Square root of -1 is just I, right? Bring that all the way down. So it's I. Wait a minute. We did all that math and all we got was I. Well, let's try I to the 6th. There's a pattern here that I'm trying to get you to see. Okay, well, we know that all those first 4 are going to be just 1, +1. What about these two? I get a -1, -1 times -1, -1. What the heck? There's a pattern that repeats itself. As the power, the exponent of I increases by 1, it just repeats this pattern. You have I, -1, -I, 1. So if we have I to the 9th, we will get I again, I to the 10th, get -1 again, I to the 11th, we would get -I again, and I to the 12th, get 1. Those 4 answers just keep repeating over and over again. And if you just try to remember the multiple of 4 is where the +1 is, you will always be able to figure out it quickly. What if we had I to the 44th? It's just 1, right? Because 44 can be divided by 4. What about I to the 43? Oh, so close to 44, but it's 1 lower. It's -I. About I to the, I don't know, 298th? Well, 300 can be divided by 4, right? This is an even number, so but it's not divisible by 4. So close, but it's still an even number. All the even numbers become -1. The ones that don't go into 4 anyway. So that's just -1. And any odd number is either going to be I or negative I. You just got to figure out what's the closest multiple of 4. Does that make sense?